Greetings, children. This is your first review primer for the evil trig. So, hope you watch this, take notes, you can rewatch it, and with luck, you will feel more comfortable around trig. So first we're going to begin with a triangle trig refresher, and we're going to end with learning a little bit about radians. And so this will be your first foray into sort of pre-calculus, calculus trigonometry, which is a little more advanced than geometry trig. Okay, so you probably remember these basic trig functions here from geometry. Let's call this theta, and we will call this side A, and this side B, and this side C. Okay, remember that the sine of an angle is a ratio. Input is an angle, output is a ratio. So the sine of this angle here would be A over C, or opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember that tangent involves the two legs, sine and cosine involve the hypotenuses, hypoteni. Now, something that you probably did not learn in geometry is that there are reciprocal functions for each of these trig functions here. The reciprocal of sine is cosecant, so we could think of cosecant as 1 over sine. The reciprocal of cosine is secant, so we can write secant as 1 over cosine. And cotangent is equal to 1 over tangent. You could also think of the ratio of cosecant as hypotenuse over opposite, which is the reciprocal of sine. I wouldn't do that. I would just remember cosecant as the reciprocal of sine. So if you wanted to find the cosecant of theta, you would find the sine of theta, which is A over C. And then the reciprocal of that would be C over A. So that would be the cosecant. I know that you would like for the cos to go with each other. There's a different purpose for the sine and cosine, secant, cosecant, tangent, cotangent. So you're just going to have to deal with that. Sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. Okay, remember these reciprocal functions. Okay, the other thing that we're going to have to remember from geometry is our special right triangles. We have two special right triangles, our 45, 45, 90 triangle and our 30, 60, 90 triangle. I have to let the dog out. Okay, so this is our 45, 45, 90 triangle, and this is our 30, 60, 90 triangle. And these are kind of fundamental things that we need to know in calculus. We just kind of have to know them by heart. And that's because there are a lot of sort of naturally occurring 45-degree angles. This comes from a square. The 45, 45, 90 comes from a square. And the 30, 60, 90 comes from an equilateral triangle. And if you put six equilateral triangles together, you get a regular hexagon. And all of those are pretty frequently occurring shapes in nature or in architecture. And so they're ones that we sort of bother to memorize. Kind of like this vocabulary that we memorize just so that we can speak the language better. So I usually think of my special right triangles as having ratios of 1, 1 root 2 and 1, 2 root 3. The reason the pictures have the x's in them is because that if this were 3, this would be 3 root 2, and that would be 3 root 2. So that may be how you learned it in geometry, but it's just as well to know them like this because these are reduced to lowest terms. Okay. So the sine of 30, therefore, would be 1 over 2. The sine of 45 would be 1 over root 2. And the sine of 60 would be root 3 over 2. Okay? You could probably fill these in by yourself here. Cosine of 30 is root 3 over 2. Cosine of 45 is 1 over root 2. And cosine of 60 is 1 over 2. That's kind of neat. And then this is 1 over root 3. You know that because the 30-degree angle is the little guy, so the side opposite the 30-degree angle is the shortest side. 1 over root 3, that's the long leg. Okay? 1 over root 2. Oops, I'm so sorry, that's not correct. Tangent of 45 is, of course, 1 over 1, and the tangent of 60 is root 3 over 1. But sometimes you'll see this and this in rationalized form, and this. So this in rationalized form would be root 2 over 2, and tangent in rationalized form would be root 3 over 3. I'm going to refer to them this way, and they can be converted as needed. Now, the next thing you're going to have to get comfortable with is the idea of radians and degrees. Radians are just another unit of measure for angles. We think in degrees, just like if you're from the United States, you think in feet and inches and miles and yards. And if you're from an Asian or European country or anywhere else in the world that's reasonable, you think in metric. So we think in degrees. We can estimate what 60 degrees looks like or what 90 degrees looks like. But radians is just another way of measuring angles. It's a different unit of measure. So, radians is another unit with which to measure angles. But it, so sorry, look at me here. But it can also be used to measure lengths which make it more flexible than degrees. 1 radian is equal to the central angle which intercepts an arc, the length of the radius of a particular circle. I know that doesn't make any sense when you read it. It doesn't even make sense to me, and I know what a radian is. So let's look at this. So here's my angle, here's my central angle here. And what I do is I take my radius, which is that leg there, and if I put it on the edge of the circle like that, so that that arc is the length of the radius, then this angle is 1 radian. Isn't that fun? Okay. So if you can imagine how many of these will fit going around the circle, you could also imagine to yourself, like, how much is that? You look at it, you eyeball it. It looks like, well, like 60 degrees, right? It's roughly like 60 degrees. It's close. It's close. It's actually a little bit less. All right? So what I want to explain to you is how many radians would be in a full circle. Think about it. How many times does the radius, how many radii do we need to get all the way around a circle? Well, we need about 6, maybe like 6.28. Does that number ring a bell to you? It's 2 pi. That's how many radii it would take to get all the way around the circle. 2 pi. So that's really cool, right? Because that means that 2 pi radians is equal to 360 degrees. And even better, use a different scale here, pi is equal to 180 degrees. So you might want to pause the video and just think about that for a minute, because that's pretty cool. So pi radians, which is a little over 3 radians, is 180 degrees. Okay? 1 radians. Come on now. 1 radian is about 57 degrees. Okay? It's between 57 and 58 degrees. Okay? And this all makes sense, because it takes 2 pi to get all the way around the circle. It takes 360 degrees to get all the way around the circle, so those two things are equal. And that's fabulous. So, oops, it's not time to practice our conversions yet. With this said, if we know that pi is equal to 180 degrees, then pi over 2 would be the same thing as 180 over 2, which would be 90 degrees, right? Pi over 4 would be 180 divided by 4, which is 45 degrees. That's pretty awesome, yeah? What if we divide it by 3? Pi over 3. Well, that's going to be 60 degrees, because 180 divided by 3 is 60 degrees. And what about pi divided by 6? So 180 divided by 6 is 30 degrees. Alright, so these are kind of your basic building blocks of radians. Let's say then we have 3 pi over 2. Well, each half is 90. So if we have 3 halves, we have 270 degrees. Alright? So let's say we have 3 pi over 4. That's 345 degrees. That makes it 135 degrees. Pi over 3, 2 pi over 3 is equal to 2 60s, which is 120 degrees. Pi over 6, well, we don't have 2 pi over 6, or 3 pi over 6, or 4 pi over 6, because as you can see, those would all reduce. But we could have 5 pi over 6. 5 pi over 6 would be 5/30s, which is 150 degrees. Pretty cool, right? Well, let's keep going with this idea. What would 5 pi over 4 be? Well, it would be 5 45s, which is 225 degrees. And 4 pi over 3 would be 460 degrees, which is 240 degrees. And let's try 7 pi over 6, which equals 7/30s, which is 210 degrees. This is pretty cool, right? And let's see if we can fit any more on here. What about 7 pi over 4? Well, that's just shy of 360 degrees, right? Because that would be 8 pi over 4. So it's basically 360 minus 45, because 8 pi over 4 is 2 pi. Or you could think of it as 7 times 45, which I think is harder. So that's going to be 315 degrees. Okay, so there's 5 pi over 3. That's going to equal 5 times 60, which is 300 degrees. And lastly, there is 11 pi over 6. It's always hard to write. You have so many sticks going on. So 11 pi over 6 is 11/30s, which is 300. and 30 degrees. Okay, it's a little lesson on radians and refreshing your memory on special triangles. So if you want to practice conversions, you can go here to quizzes. This is open until, I think, November 3rd. And I will try to update this. You can also make yourself a Quizlet with all of those angles that I just gave you on the previous page. You can go back and do that. And you should get comfortable with these because radians are a new way of life for you.